Okay, let's dive into this. Here's a wild thought. A pressure vessel can be completely built, welded, tested, and ready to go, but until it gets its official paperwork, legally speaking, it doesn't even exist. Today, we are decoding a vessel's legal identity, its nameplate, and its data report. You can really think of it as the vessel's passport. So here's our roadmap. First, we'll talk about what actually makes a vessel a legal asset. Then we'll look at the famous use stamp, decode all that critical data on the nameplate, spend some real quality time on those all-important RT markings, and then we'll wrap up with the vessel's complete biography, the U1 data report. All right, let's get right to a core idea that, honestly, it surprises a lot of people. Just picture this. You've got this massive steel object sitting in your shop. It's passed its pressure tests, it looks like a vessel, it acts like a vessel, but legally, it's not one yet. Not in the eyes of the law or the ASME Code anyway. So this brings up a really great question that trips a lot of people up. After a vessel passes its hydro test, is it officially a vessel? The answer, and you might be surprised, is no. The hydro test is an absolutely critical physical milestone, for sure. But its legal birth, well, that happens a little bit later. This slide really clarifies that key distinction. Over on the left, physically finished means, it passed its tests, it's structurally sound, but you cannot legally put it into service. On the right, legally certified, well, that means it has the official stamp and all the required paperwork. That makes it a legal asset, completely approved for operation. That's the transition we're focusing on. So how does a vessel make that jump from just being a physical object to a legal one? Well, the very first step is getting its official seal of approval. And that seal is the ASME U stamp. Now, this isn't just some simple mark. It is a legal declaration. It means the vessel was built in strict accordance with the code, and, just as important, that an independent, authorized inspector has verified and signed off on every single step. In a lot of places, without this stamp, a vessel simply cannot operate. Period. Right, so if the U stamp is the official seal on the passport, the nameplate is that main page with all your vital statistics. It's like the vessel's VIN number on a car, a super quick reference for its entire identity. Every single ASME nameplate has to have this essential information. As an inspector, this is your first stop. Right away, it gives you the critical operating limits, traceability right back to the manufacturer, and its age, all in one convenient spot. Let's break down the two most important limits here. First step, MAWP. Maximum allowable working pressure. The best way to think about this is like the red line on a car's tachometer. It is the absolute pressure ceiling at a specific temperature, and it's the primary safety boundary you never, ever cross. Now, equally important is the MDMT, the minimum design metal temperature. This tells you the coldest the vessel can get before the steel risks becoming brittle, kind of like glass. If you operate below this temperature, you could have a catastrophic brittle fracture. It is a critical parameter for safety, especially if you're in a cold climate or dealing with cryogenic services. Okay, now we get to the real heart of the nameplate story, the RT markings. These little codes are literally the fingerprint of the vessel's construction quality. And you know what? Understanding them is completely non-negotiable for any inspector. And I'm not kidding when I say this. This is probably the single most common topic you will find on certification exams, like the API 510. So why? Because these markings directly relate to the vessel's integrity and the level of confidence we have in its welds. Now, what's really fascinating about this slide is how it perfectly lays out the hierarchy of quality. The RT stands for radiographic testing, which is basically using X-rays to look inside the welds for any defects. The amount of X-ray that's performed, from complete to none at all, directly determines a critical engineering value we call joint efficiency, or just E. So let's focus on the two you're going to see most often. An RT1 vessel, that's the premium build. Every inch of every single pressure weld has been X-rayed. That gives it the highest possible joint efficiency. An RT3 vessel is what we call the industry workhorse. It uses spot radiography, which is more of a statistical sampling method, and that results in a slightly lower, but still very robust, joint efficiency. A joint efficiency of 1.0, that's the gold standard. It means we have 100% confidence in that weld. When we do our calculations, we get to treat that weld as being just as strong as the base metal itself. There's no penalty, because we've looked at everything. Now for RT3, we have a joint efficiency of 0.85. Now listen, this is really important. This doesn't mean the weld is weaker. It means we're applying a 15% factor of safety in our calculations to account for the fact that we've only spot-checked the welds, not examined every single inch. It's really a measure of our inspection confidence.
Of course, there are other crucial markings. If you see HT, that tells you the vessel went through a stress-relieving heat treatment after welding. W is the very common marking that just indicates it was welded. And if you see an L, you need to pay very close attention. That means the vessel was designed for lethal service, which carries a whole extra set of incredibly stringent requirements.
So the nameplate gives us that critical summary. But where do you go to find the vessel's complete, unabridged life story? Well, that is in the manufacturer's data report, also known as the Form U1. This is honestly the best analogy there is. If the nameplate is the cover of the passport with the key info, the U form is all the detail pages inside. It documents every single material, every calculation, and every signature. The U1 is the single source of truth for how that vessel was built. It documents everything: the exact materials used, the design and as-built thicknesses, the specific welding procedures used for every joint, and maybe most importantly, it carries the legally binding signatures of both the manufacturer and the authorized inspector. So, the crucial point is, this isn't just some administrative paperwork you can file away and forget about. It is the legal document that proves the vessel was built to code. From a QA/QC perspective, let me be clear. If you lose the U1 form, you're in trouble. It can effectively make the vessel an untraceable, unusable asset. And that brings us to the final and most important point of all. You can decode the nameplate, you can review the U1 data report, and everything can look absolutely perfect on paper. But that's just the start. Your job as an inspector is to take all that information and verify that the physical vessel right there in front of you is in fact safe to operate. The paperwork is the map. You still have to walk the territory.